Already talk in the second track. We're going to be talking about NixBSD.
Which is, you might be a little surprised to hear about BSD at a Nix conference, but, well, the PlanetNix people were the ones who approved it, so blame them, not us.
All right, let's get started. But first, a few words about your presenters. You first?
Yep. Hi, I'm Artemis. I am a software engineer at Obsidian Systems. For work, I work on Nix, the Nix daemon, Nixpkgs, and other things like this. And we are looking for clients if you want NixBSD work done. I used to do CTF at PPP, and I've done a lot of competition, and I have the commit bit at Nixpkgs because people were getting annoyed at how many FreeBSD PRs I was making.
I'm Audrey. I'm a PhD student at ASU. I also have a startup in Motion Labs where we do computer security, binary analysis, decompilation, consulting, and development. So hit me up. I do CTF as well. We met through CTF. I do Nixpkgs' work because of the BSD stuff. But generally, I'm just here to have a good time.
All right. Okay. So first, let's go into what is NixBSD. So Nixpkgs is great. It has support for cross-compilation. It works on both Linux and macOS and has support for many more systems if you can build it. And it's cross-platform, but unfortunately NixOS isn't. The operating system built on top of it really wants to be Linux. So we want all the benefits of NixOS, the static system that you can build, the single centralized configuration, but we want it on FreeBSD instead of Linux with all the benefits that comes with.
And now it sort of exists. You can run a nascent FreeBSD system built through Nix. That is the NixOS configuration built with Nix and with the NixOS module system. You can make it happen. It is a little on the rocks. I don't recommend it for production use, but if you want to see it for production use, please. We'd love some PRs.
Yeah, everything's in Nix, even the kernel's built through Nix. So first, let's talk about what is in NixBSD. There's kind of three main parts. First, there's Nix. This is the same as on NixOS, which is the Nix service. It's written in C++, and it has required the most technically novel changes. It is the thing that sort of makes all the build, and it isolates each build from each other. And this has required a lot of changes and a lot of debugging, but we have something functional now.
Meanwhile, over on the Nixpkgs side, we've got an enormous amount of work that's gone into just making sure that the build instructions over in Nixpkgs work nicely for the stuff that is the FreeBSD stuff, and then building everything else for FreeBSD. Because in order to have a computer, you've got to have a lot of software, and you're not going to be able to find all that software in the FreeBSD monorepo.
And then on top of that, there's NixOS. This is sort of the same NixOS, Nixpkgs divide that they're in the same repository, so you might kind of confuse them when you're on Linux. But on FreeBSD, we've moved it out into a separate repository just to make it a bit simpler for our own work. Now a bit more info on BSD, because I've mentioned this but haven't really explained it. It's a lineage of operating systems. There's a number of different BSDs, and they're all sort of based on Unix. They aren't exactly the same as Linux, but they have somewhat similar ideas. It's based on the original Unix. It's quite old, and they've been forked a lot over time, each one having their own kernel and their own pieces of software, and it's just been various disagreements that led to it.
Yeah, it started with the original Unix, which was then re-implemented as a software project at Berkeley, so you get Berkeley software distribution, which was then re-implemented as open source for 386 BSD, I think? Yeah, which was then forked into FreeBSD and NetBSD. If you've ever seen those pictures of the timelines of Christian denomination forks, it looks a lot like the pictures of the timelines of BSD forks. So I'm not sure what we should be taking from this, but it certainly is interesting.
The fun thing is not all those are BSD, but we tried to explain the BSD sysv split, we'd be here all day. So I guess the big thing is that BSD isn't Linux. It uses a completely different kernel. And it has conceptual similarities with Linux. They're both kind of based on the ideas of Unix around sort of files and syscalls like that. And even if they weren't sharing the same source code. And eventually they standardized on POSIX, which has a basic set of APIs that BSD and Linux implement. So a lot of software that works on one kind of works on the other. There's some architectural differences, though. the kernel and the user space are versioned together. Like on Linux, you'll have the kernel, and you have like glibc, that's where the whole GNU Linux come from, and muzzle, and those are kind of separate things. And then there's like ifconfig and all these other tools. On FreeBSD, everything is in one repository. It's down to the kernel, down to the basic tooling, and there's other packages you might want, like Xorg or Wayland, and those are out of tree, and those are a real different thing. They're even installed in different ways.
So most of the time, because conceptually things are similar, you can get something built for Linux to build for FreeBSD. It's generally possible, but when you're using like really low-level architectural details of the operating system, like for example, udev or anything that systemd does, it's not going to be very portable. So you occasionally need to be able to like shim stuff in order to make a program that wants to run on Linux run on FreeBSD.
So the first piece of the puzzle in those three parts we mentioned is going to be Nix. So that is the base Nix daemon, tools like Nix build, and able to manage the Nix store on FreeBSD. So it needs work. Well, we don't need it if we're cross-compiling from Linux. If we are on Linux and we use Nix, the Linux Nix daemon, and we say, hey, build the FreeBSD kernel, then that will work. We'll just have a FreeBSD kernel built from Linux. But if we want to run FreeBSD, then have on FreeBSD to build Linux or to build the FreeBSD kernel or any other package, we will need some support. The basic support of just like building on FreeBSD and managing the store predates us. Other people have worked on this. But if you want it to work better, you're going to need the garbage collector and sandbox builds. Garbage collector is just make sure you don't delete any running programs when you run Nix store garbage collector, whatever it's called.
Yeah, so it involves just interrogating the kernel interfaces to make sure that you're not going to, that there's more live Nix paths than just the environment and just the profiles would indicate. Meanwhile, over in the sandboxing side, like the miracle of Nix is that it provides a totally isolated chroot environment with only the dependencies you've explicitly declared. And that's really good. We did have a version that worked without the sandbox at one point, and it was just a nightmare. Don't recommend it. So instead, you need to use an equivalent FreeBSD technology in order to implement the low-level Linux sandboxing.
We'll talk a bit about that later. Well, but first let's talk about the garbage collector. This is pretty simple. Well, conceptually simple. It's kind of hard to say simple for any part of this. But you look through all the list of live processes, you find what kind of files it has open, its libraries, its binaries, things like that, things in the environment variables. And you just sort of see if there's a Nix path in there, you just add it to the list of don't delete this. On Linux, that's just made by going through /proc as root. You just look at every process and look at its info. On FreeBSD, there's technically a /proc, but it looks different and is deprecated, and you really shouldn't use it. So instead, use libproc, which is a sort of FreeBSD library that they provide to get that same sort of info directly from the kernel without going through their file system interface. That was mostly just kind of taking the same ideas from Linux and just kind of moving the code around.
Meanwhile, the sandboxing stuff's a little bit weirder, because like on Linux, the sandboxing is provided through C groups and generally namespaces, where you say, oh, I've got a mount namespace, which is just sort of this process gets a different view of what mounts are on the system. But on FreeBSD, the equivalent technology is jails. And jails tends to look a little different than containers, partially because they're older and partially because they're more specific. Well, less specific?
Yeah, and they're more designed to look like what you'd have with an LXC container on Linux. So that older tooling, not like the fancy Docker stuff.
So jails are just sort of a one monolithic architecture for providing isolation of many kinds, as opposed to namespaces, which provide many techniques for doing many granular kinds of isolation. And this works generally okay, except for like, because FreeBSD expects you to be using jails on like a per system configuration level, as opposed to just an ad hoc system, some of the pieces of configuration are system global, like the devfs rule set requires like a system global configuration, which is really annoying.
And there's some other annoying problems, like you're assumed to be running the full FreeBSD environment with the full RC and everything inside of each jail, but we're not doing that. We're trying to have a really minimal setup. And there's kind of two places where they want you to shell out to do something. The biggest ones are for if config. Say you need to set the loopback interface to be up and give it 127001. FreeBSD doesn't do that by default. You're supposed to call if config just as a command, but we didn't want to do that, so instead we figured out what if config was telling the kernel, and we just re-implemented that. Even a more annoying part was etc password. On Linux, there's just etc password, a text file, but on FreeBSD, they've decided that's too slow or something. So instead, etc password is etc master.password, which is a binary database that is generated using pwd make config or something. I don't remember the exact command name. But that was another thing we would need to shell out for, and we just didn't want to do that. So I noticed that the database was versioned and had not been changed since 2003. So I just re-implemented the database creation thing in C++ and stuffed that into our NixPR, and now we don't need to shell out. And another kind of feature that we haven't implemented yet that we'd like to is the read-only Nix store. So we've mentioned that Linux has these mount namespaces where each process can have a different view of what's on the file system, what's mounted, what's not there. On Linux, you do read-only Nix store by just mounting over for everyone, saying Nix store that's read-only. It's a mount from Nix store to Nix store that's read-only. Then the Nix daemon enters its own mount namespace and just kind of remounts over that and says actually Nix store is read-write. But in FreeBSD, you can't do that. Either it's read-only for everyone or it's read-write for everyone. We have some proposals to change that. So we can use the same sort of nullfs is Linux bind mount tooling, but we thought maybe we could have a Nix RW store instead of Nix store and kind of read-only bind mount to that to Nix store, and might work. We're going to have to do some more investigation, and there's a lot of sort of small things like that to make NixBSD more usable just throughout the entire system.
And I can't emphasize enough, as we're talking about this working on CPP Nix, that the amount of intensive systems debugging that goes into programming and debugging these low-level features of interacting with the FreeBSD kernel was nightmarish. Like, the FreeBSD documentation leaves a lot to be desired, though it is getting better. Like, we started this project on FreeBSD 13 and then 14, now it's 15. And I have seen the documentation get better, but very frequently you see an error no pop out of a syscall, and you have to say, well, let me go read the kernel source.
Yeah, the kernel source is easier to read than Linux, but it's still generally better to not have to read the kernel source. It's just a huge pain to find what you were looking for.
So that was Nix, where we can build something, but what are we going to build? That's the domain of Nixpkgs, our large database of building instructions for the Nix ecosystem. We're going to dive in to how we messed with Nixpkgs. So the first thing, that's a font error. I guess I'll just do this ad hoc. The first thing that you have to understand about FreeBSD is that you need to get stuff out of the monorepo. So you've got the FreeBSD monorepo. It's got various software. It's got various both in-tree software, and that it's got some vendored out-of-tree software with like patches applied. Like, they've got patches to Clang. It's kind of a mess out there. So we need to build stuff out of the FreeBSD monorepo. This is a feature that existed in Nixpkgs prior to the start of the NixBSD project, but we were able to improve it quite a bit. So up on the screen, you can see a sample derivation text written in the Nixlang for how you would build the BSD label binary, which is useful for just like manipulating file systems on a FreeBSD machine. So here it provides, here are the paths, and the path that we're going to run the make file out of in order to build the program, any extra paths out of the monorepo that need to be pulled in order to do the subsetting correctly, and we just have an additional scope in order to manage the rest of the dependencies in the FreeBSD tree that we would need to build this. So here we have libgeom as a dependency. And you can't really see that in the little black on black text, but one of the magic things is that the source code subsetting happens out of the repo, and then we apply our patches. So if we're doing patch development and we make a patch that changes just the parts for OpenSSH, let's say, we don't need to say, we changed the whole monorepo, let's go rebuild libc.
Yeah, we can improve this in the future to reduce the number of rebuilds by, say, like making each of these subset sources fix output either through some sort of hack or through CA derivations, but that's not necessary for building, so we haven't really done it.
So when it comes to actually building stuff, just because you build something doesn't necessarily mean it's going to run. Like, the FreeBSD libc has an enormous number of, like, paths from the file system hard-coded into it. Like, there's so many user shares in FreeBSD libc if you run a strings on it normally. So, like, you probably, on a NixOS system, want to point those at /run/current system software, but it's not super clear that that's good always, because you can also just install Nix on a normal FreeBSD system, and they're not going to have a run current system. This problem sort of exists on Linux as well, but to a much lesser extent.
Yeah, it's mostly just run OpenGL driver, and there's simple tools to work around that.
So when you actually want to build this stuff out of the repository, though, it's expecting a different build environment than what the Nixpkgs standard ed usually provides. For starters, it wants all the BSD tooling, so like BSD make, the BSD flavored xarg, sed, install libcurses, awk, and the shell even. And we worked around these in a couple of ways. Like, for example, bmake, we can just build straight up because FreeBSD does provide a bootstrapping mode where you can cross-build the stuff for Linux and then use it on Linux to cross-build for FreeBSD. It's great. It's so much fun.
Unfortunately, other BSDs don't have this, so that's just a ton of hacks. Like OpenBSD is something we've attempted some work on, but we're mostly talking about FreeBSD because that is easier and probably more useful.
And so then just some general notes on the way that the FreeBSD runtime wants to work. There's just a lot of weird differences that you don't really expect when you're coming from a Linux land. Like, for example, you link against the environ variable. You expect to be able to do that in a shared library, right? Well, if you do that on FreeBSD, you're going to get an issue because it's defined in CRT0, which isn't linked for shared libraries, as far as I'm aware. So it's very frequent to try to compile a package in Nixpkgs for FreeBSD that you've never tried before. You get undefined symbol environ, you sigh, and then you pass the linker flag to ignore undefined variables.
Yeah, this just happens all over the Nixpkgs tree. There's so many pieces of Nixpkgs that are just like making some PR that's some tiny like new environment variable or a little flag to add, or even just saying, hey, yes, this builds on FreeBSD, don't make it Linux only.
But such is the life of distro managers. And what are we? Distro managers. Meanwhile, on the Clang side, we had some weird issues like trying to build stuff in the FreeBSD tree just because the FreeBSD libc headers seem to redefine some of the stuff that's normally provided in the Clang headers, and we genuinely spent weeks trying to reverse engineer what the correct way to do this was, but we ended up just setting like a barrage of preprocessor defines in order to stub out half of them.
It works, I guess, is the best thing you can say about it, but
it works. Let's move on.
Yeah.
Then there's the unwinder, which is sort of necessary for like if you've got like exception handling in C++ or Rust or anything. Usually, FreeBSD uses a library libgcc, except surprise, it's not actually libgcc. It's libunwind from LLVM. It's probably just named that because they probably just used GCC unwind back in the 90s, and now it's like, oh, I don't need that anymore. I'd prefer the LLVM version. But wait, I don't want to change my SO name. So now they just have this name that's just wrong, and so it messes up configure scripts in a lot of other projects.
Yeah, and I guess this is just kind of an inherent issue to FreeBSD, and it's when FreeBSD works around something, we have to work around it in the same way, and there can be sometimes useful locations for that, like the ports tree, where FreeBSD gets all of its extra software. They have their own patches. So the Clang redefinitions only apply inside of the FreeBSD, like their own source tree, not outside of that. But for the environment variables and the unwinder and things, those are inherent with building for FreeBSD, and we don't try to work around them in standard N. If something needs a change to build on FreeBSD, then we are going to have that change in Nixpkgs to build on FreeBSD.
Because like we can make changes in the standard N for when we're building from FreeBSD to FreeBSD, the native FreeBSD standard N. We have total reign over that, but we probably shouldn't go making a lot of changes in the Linux standard end just because target platform is FreeBSD.
Yeah. We often just find it easier to take whatever patches and such end up in the ports tree and try to upstream the fixes to the original projects.
Yeah, the FreeBSD ports tree, which is where they keep their software archive for how do you build all sorts of stuff for FreeBSD, has been very invaluable because it contains basically all the known cases of, oh, you need to apply this patch in order to get it to work on FreeBSD.
Okay.
We'll take it. Meanwhile, you just need, oh my gosh. Like, so you run configure, right? But what happens before configure? There's how does the invocation
It's
do?
like
Autoconf and
auto
auto tools and autoconf and auto reconf?
Yeah, I think it's something like that. And there's automake somewhere. I don't know.
Don't worry about it. Except we have to worry about it. So there's several issues that arise when configuring packages for FreeBSD. The first is that for some reason, a lot of people just seem to believe that you need to include the FreeBSD kernel version number or libc version number in the target triple, which sort of betrays a belief that FreeBSD doesn't have any sort of backward compatibility, which it really, really does. I promise, FreeBSD
Yes,
does.
I'd like to note that FreeBSD has compatibility in the kernel for syscalls from the 4.3 BSD from 1986.
Yeah, GCC is a major offender. It will actually just straight up not build if you say, I would like to build for an unspecified FreeBSD. It'll say, you can't do that.
I guess you.
So now let's talk about the FreeBSD native standard end. So when you build something, the way you generally produce a pure bootstrap, a pure building environment is you start with some sort of seed binaries, and then you gradually use those to build more and more source until you can cut the seed binaries out of the runtime closure of your build tools entirely.
For to be clear, this is for like with Nix sandboxing builds from FreeBSD to FreeBSD.
Yeah. So what we've done is one of the first things I actually did for this project back in 2023, something horrible like that, was just trying to get the FreeBSD standard end working again. So, because it worked at one point a long time ago, and then it rotted, and then I fixed it, and then it rotted, and then I fixed it, and then it rotted. So we ended up like building sort of a minimal set of binaries and libraries that, in order to like enable a minimal C compilation environment, just cross from Linux to FreeBSD, from Linux to FreeBSD, and then we were able to assemble like the pure bootstrap, which is just the process of iteratively replacing those seed binaries with built binaries until you've got none of the seeds left.
Yep. And then there's other issues with Linux-specific packages. Like if you're trying to build Wayland, it's going to want UDEV, and FreeBSD doesn't have UDEV. That's kind of inherent to systemd. So luckily, we aren't the first people to have this problem. There's a lot of old tools like libudev devd, which is UDEV compatible interface on top of FreeBSD's devd, or evdev proto, which is just kind of interface some headers to allow you to use Linux input on FreeBSD. And a lot of these are just kind of taken from, the ports tree, and they pull it from other software that people have written for these same problems.
There are some situations where this isn't really going to work, like for example, .NET or Rust on FreeBSD AR64. There's no way to bootstrap yourself into existence with those natively. So what we might need to do in the future in order to support FreeBSD's building for itself these projects is to use the FreeBSD Linux emulation support, which is just a kernel module that works.
Yeah, we just need to make sure that it doesn't need any Nix changes, because that could cause some more issues. Now, I guess what you've actually been waiting for, which is NixOS, the real OS on top of this. Before now, we may be able to do things on FreeBSD, but it's definitely not NixOS. So I guess we want to talk a bit more about what is NixOS, because it's in the Nix packages tree, but it's really not the same piece of software. The most important part is called eval modules. You have a bunch of modules that say, hey, here's an option, like, I don't know,
Yep.
Yeah, networking hostname. And that will get defined somewhere. And then And that will get defined somewhere, and then other options will be defined based on other options, and it just kind of cursively goes down. So you might have like your FQDN is defined after your host name, and then you'll have an etc file defined after your FQDN and things like that. And all of those get kind of combined into one giant option called system.build.toplevel. That includes just everything you'll have. It has your environment variables, your software, your kernel, and inside of that, there's a few files. It's a big directory. Activate is what sort of moves files into place. It makes the environment variables, it starts the services, it puts things in etc, things like that. We've had to rewrite a lot of that. We've had to rewrite some of that for FreeBSD. We could reuse a lot of it. Another thing that calls activate is switch to configuration. If you've ever done a NixOS rebuild, that calls switch to configuration, and it calls activate if you tell it to switch. Otherwise, it just tells it to install the bootloader. And the way it installs the bootloader is by looking through all your versions of NixOS or whatever from your list of profiles, and it finds boot.json in each one. That's been around for a few years, and it defines the kernel options, and a few things like that inside of a JSON file. We've been able to mostly keep the schema from Linux, but FreeBSD is a bit of a different in how it boots the kernel. Like it kind of wants the module path and the environment, like the settings to the kernel are set as, it really wants to know them as like a dictionary. So we've had to make our own settings for that, but otherwise it's mostly compatible with the existing nixboot.json, and we can use existing tooling for it.
So meanwhile, when you get to userland, you need to run some services. For that, we've got our init system. Our beautiful, beautiful, dependable systemd over on NixOS simply will never run on FreeBSD. It's completely out of scope. Systemd is so Linux specific it hurts. And furthermore, NixOS is just really, really wedded to systemd. For a very long time, the only way to configure a runtime service on a boot time service on NixOS was to say, here's my systemd unit, more or less.
Yeah, many services, instead of just defining a service in Nix configuration, they say, hey, there's already a .service file in my package. Just put that into the NixOS system. And Nix never sees what's actually happening there. It just goes directly from the package into the system, and it gets parsed at runtime, and Nix just doesn't see it at build time.
So meanwhile, on FreeBSD, we have an old-style RC init system, just a pile of shell scripts. This works. We can work with this. So for FreeBSD purposes, we basically just built a whole nother service layer that can just you just configure services instead of configuring them for systemd. You configure them for FreeBSD RC.
Yeah. RC provides many of the same sort of tools systemd does, although often it requires a bit of extra configuration. Like FreeBSD services can pretty easily do ordering. You just say you rely on these things and provides these sort of names, and other packages will rely on it, and that maps kind of well to systemd units. This isn't true on all BSD systems, but again, FreeBSD is the most useful and probably the most fleshed out. In the future, we'd like to use modular services. This is a RFC that has been merged, and there's been a tiny bit of use just as demo services. But the idea is that each service can define a different configuration. So it'll say, hey, if you're using systemd, it'll use this configuration, make a systemd service. If you're using FreeBSD RC, then it will use this FreeBSD RC service. And if you're using, say, S6 RC or some other Linux RC, if you want to not use systemd, then that could be supported in the future.
Another approach that we've been considering taking in the future is just re-implementing some subset of systemd. Like initware is a project that does this. Initware doesn't work. I have like some toy experiments with re-implementing some pieces of the systemd unit architecture just for FreeBSD, and it kind of works, but also, even if it did work, it kind of raises an interesting question about the future of this project, which is like the whole reason that we want to use FreeBSD, well, one of the whole reasons, is that we really like heterogeneity in software. We really want to be able to support a diversity of options when it comes to being able to configure your computer. So like, we don't want to just stick to systemd.
Mm-hmm. I mean, we don't even need to take systemd wholesale if we want to switch to the FreeBSD RC. One thing we do is we use something called mini temp files. So systemd temp files makes all the symlinks and a lot of kind of temporary directories. And instead of just kind of porting all of that to a bunch of FreeBSD scripts, we decided it would be easier to just rewrite it in Rust, basically, and that is what we do, and we don't really have plans to change that. It's just the easiest way of doing what we want. And I guess now we need to talk about the bootloader, which is what gets us from the UEFI or whatever firmware, and you press the power button up into a fully functional system. And on Linux, you have a bunch of options. You have systemd boot, you have grub, you have other things probably. But on FreeBSD, there's only really one option. FreeBSD is its own boot protocol. It has a lot of options that you can add into it, like FreeBSD supports, say, loading kernel modules at runtime or at boot time. So we just had to figure out how to use the FreeBSD bootloader. Luckily, it is configurable. It has a built-in Lua interpreter, and a bunch of the front end is written in Lua. So we just modified the front end. When we run NixOS rebuild boot, it kind of copies all our configuration, all that Lua, and uses a bash script to turn those boot.jsons into a big Lua array. And it works. You can select different configurations on, like in the bootloader, there's a little button, and it'll switch to your next NixOS configuration in FreeBSD. And there's a bit of a difference in how it does boot, though. On Linux, we use an initRD most of the time. That is when the bootloader loads this kind of tiny file system that on Linux starts in here. And it might be systemd, it might be a shell script, something like that. And then it goes through and it mounts the main file system. It loads the modules it needs, might decrypt the disk. And then it switches over to the main rootfs.
Meanwhile, in FreeBSD land, all of those responsibilities are traditionally part of the bootloader. The bootloader's got a ZFS driver and can do decryption. The bootloader can nominally do many, many things. But ultimately, we have a tool called the init memory disk, which is basically sort of a RAM-based file system that we can use in FreeBSD, and we do have to do that for a pivot root in order to support basically, we have to do a pivot root in the case that we need to use a file system that the bootloader doesn't know how to handle. Right now, the only case for this is the 9p file system.
And otherwise, we don't really need that in initfd, and we don't want to bring Linux isms into FreeBSD, and we don't absolutely have to. So now let's talk about how the NixBSD project is going. We've talked about how it works, but not really what's happening right now. The biggest thing we want is upstreaming, because that reduces the maintenance burden on us a lot. With Nix, we have some PRs ready. We've been, over this course of this conference, we've been rebasing some of them, and we think we have them working. We just need people to review them and get kind of final comments in, and hopefully we can get everything merged into CPV-Nix, or into the C++ Nix daemon pretty soon. On Nixpkgs, the core parts are done. However, it keeps bit rotting, so we have a few PRs up, and over the past few weeks, we've made a lot of PRs trying to get all the kind of basic system working again and add new packages for various purposes into things that are working for FreeBSD.
I can't overstate. We need CI for the FreeBSD standard end. This is necessary. This is crucial. This is something that has to happen. So if you know how to make it happen, please talk to me.
Okay, and for NixOS, that's a much more complicated question. It would require some re-architecting of NixOS, and we don't really have the ability to do that. We need a lot more discussion with other people, just due to the assumptions. So the sort of status quo is that we have to maintain things out of tree. We need to keep fixing breakages, and that removes the time we have for real work. There's only really 2 main people working on this every now and then, and some other contributors. But we're busy, we have other work to do, and we have some rabbit holes we're going down. Like currently we've been working on Wayland and trying to get that working in upstream. And in the future, let's talk a bit more about that upstream NixOS.
So, as we said before, modular services should really get some more love so that we can actually use them.
People have proposed various types of portable services where you define, hey, a service looks like this, and it just works on everything. But all the systems work a bit differently, and it's never really been a great idea. There's always been too many downsides was trying to make portable services, so that's why modular services existed.
We talked about initware. Doesn't work.
And we've also had ideas for like converting units into RC scripts, but that's also
Sort of a pipe dream as well.
Yeah.
We would really like to be able to improve the testing story around NixBSD, because NixOS is really cool with the way that VM tests work. Something similar should be possible with FreeBSD. It'll be a little bit more difficult because QEMU doesn't support direct booting in a FreeBSD kernel, but there's workarounds. We should be able to get it to work.
Other useful things might be ZFS declarative configuration. So you could just say, hey, make these ZFS units and set these settings on them. And that would be very useful if you want to, say, make a FreeBSD file server, one of the things it's really useful for. And that would let you just have a single configuration, and suddenly you have a file server up. And
personally, I would love that in upstream NixOS. I've configured so many NixOS file servers with ZFS. It's become a little bit of muscle memory.
Mm-hmm. And as part of that file server, we'd probably want a few more modules. Biggest ones are the firewall and NFS. The firewall PF is also a thing that a lot of people like as a network firewall as your router, and there's been various FreeBSD distros for that. And hopefully modular services will let us get a lot more things onto here very quickly.
So we've been talking a lot about FreeBSD, but really the point of this project is heterogeny, among other things. So really, we want to be able to lay the groundwork for using other BSDs and other operating systems as well within the NixOS ecosystem. So we've done a little bit of work on OpenBSD. We actually, there was a demo a couple months ago of actually installing and booting a fully functional OpenBSD system that's configured with NixOS.
Yeah, we had Nginx running on it, and SSHD, and DHCP and everything.
Really, really important stuff that you definitely think about all the time.
Unfortunately, we can't really get quite as much flexibility with OpenBSD. Although it's a lot of security stuff, they don't really have containers in the same way that FreeBSD has jails or there's Linux containers. So we can't really sandbox traditionally. We might be able to use VMs on top of it, but their view is that you should use VMs, not containers, and it's kind of reasonable, but it is hard for us to use VMs for Nix builders.
Yeah, it doesn't really work with the current Nix builder architecture.
Mm-hmm. Another option is NetBSD. That also doesn't really have containers, but other people have worked on Nixpkgs NetBSD support before. We haven't really looked at it, but we know it is possible to build Nix packages on NetBSD. We haven't worked on NixBSD before, but I don't know, if we want NixBSD on a VAX, then maybe we can try that sometime. And then I guess finally there's Illumos. I know there are some users of Illumos who might want to use Nix, but it's not technically BSD, but it's kind of similar idea. We think that it's possible to do sandboxing with zones, and it would definitely be possible to cross-compile. I think there has been some work towards that before, but there's nothing upstream, and could be a fun little challenge to do if someone wants to do it.
Okay, demo time. Let's do some demo. So,
we've spent the past month or so getting all of NixBSD up to kind of working again, and we also ported everything to get Sway and Firefox and a bunch of other packages running. And by the time we had everything working, we just plugged this in. We had set up Wi-Fi, and it just immediately showed up, and we could show our presentation.
Yeah. So this is heavily dog-fooded right now, actually. I mean, I probably won't be able to use this for my day job. I'm on too much of a time crunch to use this for my day job, even though I really want to use this for my day job.
Yeah. Well, if we get a few more PRs and a few more contributors, maybe we can.
Well,
I guess
that's really all there is to it. There's a running NixBSD system right here, and if you want to ask questions about it, we will gladly take them.
Do you have Nixpkgs checkout?
Oh, I do. I do have a NixPkgs checkout. Well, we're going to do one last demo, I guess.
Do you want to build something?
I'll build something.
Oh yeah, Rust is a big example of bit rot. So there's been a few languages like Rust and Haskell. Yeah. There's been a few languages like Rust and Haskell where we spent time getting the build to work, and it works, and we merge it, and then it breaks again sometime later, and we need to remember to look at it at some point, and CI would help with that. Okay, so someone asked about pain points of modular services, And I guess the truth is I haven't looked super deeply into modular services. But
No one's looked super deeply into modular services. No one knows about modular services. If you want to help with modular services, you need to just take a deep breath, take the plunge, and start re-implementing your favorite server's configuration in NixOS as a modular service and see what happens.
Yep. So there's FreeBSD has in the ports tree for a few languages. They have like special support for. They've made their own bootstrap binaries, maybe from Linux to FreeBSD, and they just kind of posted them online. And we could probably find a way to use those, but mostly we've just been building things cross when we need to. Another issue is AArch64 FreeBSD, especially on x86 64 FreeBSD, for example, there's Rust binaries, but they don't have that in AArch64, so we'll have to find some way around that or make our own like FreeBSD does.
All right, we are out of time. So thank you all for being a great audience, and I'm going to disband us all. If you want to come talk afterwards, come talk to us afterwards, but have a great rest of the conference.
Okay, thank you.